Okay, my name is Viktor Rudko. I'm from the IBG5 at the Forschungszentrum Jülich in Germany. And today I want to present to you SimpleVM, which is a platform that enables you to utilize computational resources in the cloud for research effortlessly. And I would like to start by presenting the environment in which SimpleVM is currently primarily in use. And this is Denby and the Denby Cloud. And for that, I must introduce Denby to you first. Denby is the German network for bioinformatics infrastructure. It's the German Elixir node. And besides bioinformatics services and training, it also operates a federated cloud that offers computational resources free of charge for German academia. One can apply for these resources using a centralized cloud portal that also manages the allocation of the projects to the corresponding cloud sites. When applying for these resources, one can choose between different project types, which I will introduce to you in a moment, and SimpleVM is one of those project types. SimpleVM is operated at 4 of the 8 cloud sites in the Denby Cloud and covers about 50% of all projects that have been or are being processed in the Denby Cloud so far. The resources used in such a project range from single virtual machines with a few cores and a small amount of RAM up to complex setups with 100 VMs and thousands of cores and terabytes of RAM. Additionally to the Denby Cloud, SimpleVM is also in use at the Bielefeld University, where it is utilized for research and teaching in the context of a data science infrastructure project. So who are the users of the Denby Cloud and SimpleVM? Like the majority of the users that we have in the Denby Cloud are not IT specialists. They may know how to write small scripts, how to use the command line, basically, and how to work, run their analysis, but they don't want to deal with complex setups in cloud environments. They don't want to set any security groups and stuff. So the other project types that we offered before we introduced SimpleVM were OpenStack, Kubernetes, and Galaxy. And I would like to show you what the advantages and disadvantages of these project types are and why we introduced SimpleVM. So while technologies like OpenStack and Kubernetes allow you to configure very, very complex infrastructures or orchestrate complex applications through containers, these high configurability also comes with the obligation for the user to carry out these configurations. So as I already mentioned, the majority of the users doesn't want to deal with these configurations. On the other side, you have a platform like Use Galaxy, which enables you to start established workflows and tools in no time by using the UI of the web platform, but it only gives you limited access to virtual machines. So we decided that we need a solution in between that allows you to access virtual machines easily and securely. And I would like to present 4 core features of SimpleVM that enable you to do so. This is the streamlined VM management, the virtual research environments that we offer, the ability to conduct workshops using SimpleVM, and the cluster orchestration tool of SimpleVM. So let's start with the streamlined VM management. When we initially developed SimpleVM and introduced it to the cloud, our main objective was to shorten the time span between the actual project allocation and the scientists really starting on it. And we did so by just reducing the steps to take to start a virtual machine. So all you need to do to start a virtual machine with SimpleVM is you select the flavor, which is basically the resource definition of a virtual machine, the number of cores available, the amount of RAM available, and an image, which is the operating system or a pre-installed application running on that virtual machine. And you're good to go. You click on start, you access the virtual machine in seconds, and you're good to go. Of course, on top of that, SimpleVM offers common functionalities. You can, like, for example, in comparison to OpenStack, also restart virtual machines. You can create snapshots. You can even attach block storage to put data on these virtual machines or save the results from your computations. You can even pre-select certain Conda packages or sets of Conda packages that you want to be installed on your virtual machines. And then these packages will be installed for you automatically on machine startup instead of you being in the need of installing these packages manually. You can also provide access to other project members. So you just select project members that shall have access to the virtual machine, and for example, the public keys get copied to the virtual machines as well, and they have direct access when the machine is available. The next feature is the virtual research environments. We offer various different research environments from IDEs like Taya or Visual Studio Code up to data science notebooks like RStudio or the full remote desktop experience powered by Guacamole. And as I already mentioned, you need to only select a flavor and an image. And these virtual research environments are available as pre-built images. So you just select Visual Studio Code, for example, and after the machine has started in seconds, you are able to use Visual Studio Code within your web browser. These virtual research environments are very, very commonly used in workshops. But before I want to introduce the advantages that SimpleVM brings to conducting workshops, I would like to introduce two typical scenarios, what I would call problems that occur when you conduct workshops. Normally, you would use the local IT infrastructure of your institute, for example, to conduct these workshops. And as in many cases, the participants come from various different institutes, they normally all need an account at the local IT infrastructure of your institute. This slows down the process or makes the process of registration kind of complex. And the alternative to this would be you providing a description on which packages to install on the participants' own devices. But as the participants normally use different operating systems, different environments, this regularly leads to installation problems. And this is where SimpleVM is the solution for. So I would like to present how to conduct a workshop with SimpleVM. And you simply start by creating the workshop and creating a so-called invitation link that you then can send to the participants that shall take part in this workshop, and then can, of course, approve the registrations. And as soon as you approve the registrations of the participants, you can already start virtual machines for these participants, the same way that I showed you for the virtual machines in a normal way. But what you would normally do is you would create a so-called template packages that you need for the conduction of the workshop, all the software, all the tools. Maybe you put even some data on it, and then you create a snapshot of that virtual machine, and then use this snapshot as an image to provide the same environment for each participant that is taking part in this workshop. Then you just assign the participants that you want to start virtual machines for, and in seconds, they are ready to go. Additionally, the tutors that you manage in this workshop have access to the virtual machines that you start for the participants. So in case any problems occur on the virtual machines of your participants, they can easily assist. This allows you to conduct workshops with SimpleVM online, on-site, or in hybrid format. The last feature that I would like to present is the cluster orchestration feature of SimpleVM, which is mainly based on BBGrid. It allows you to start Slurm-based clusters, which consist of a master node, different worker node batches, and they are all combined to or connected to a shared storage. So you can run Nextflow workflows, for example, and then the certain jobs of that workflow will be distributed from the master node to the worker nodes in respect of the resource requirements that these simple jobs have. So in case a bigger job is spawned, it of course gets automatically assigned to a bigger virtual machine. So what comes on the autoscaling that we introduced. So in case there is a very big job in the job queue that the current virtual machines that are running in the cluster are not able to process, automatically a bigger flavor gets started that then processes this part of the workload, and then when it's no longer needed, automatically gets deleted again. So it utilizes you to, or it enables you to very efficiently use resources in the cloud. And it's perfectly built for the execution of large-scale workflows, for example, with Nextflow, when they run for days or weeks. So now that I have spoken about the user's perspective, I would like to have a look on the operator's perspective. So what do you need to bring to the table to run SimpleVM on your infrastructure, and what are the technical advantages that you have as an operator? Before I will speak about the requirements, I would like to highlight that you only have to run one basic SimpleVM installation, and you connect multiple cloud providers with that basic installation. And this is due to the SimpleVM client that we introduced. This is the component that is communicating between the SimpleVM basic stack and the corresponding cloud provider. Currently, it is tailored to OpenStack. but it could be easily adjusted to other cloud providers, so it could also support AWS, Azure, Google Cloud, or whatever. And the SimpleVM basic stack basically consists of Docker container and can be deployed using Ansible playbooks that we offer. So all you need is this basic stack, an pool project, how we call it in OpenStack, which is also defining the boundaries of the resources available for a certain compute location that you want to connect to SimpleVM. And then you configure the authentication authorization system by connecting the identity providers that you want your users to log in by, and you set up the gateways that enable the access to the virtual machines. These gateways also serve other functions beneath the connection to the virtual machines. For example, they allow you to save scarce resources as floating IPs, as you only need to use one floating IP to the connection of the virtual machines, as they map the internal IPs of the virtual machines to a port on that SSH gateway, and then you are able to connect to all virtual machines by just defining the IP of the gateway and the port of the corresponding virtual machine. It also enhances the security of the virtual machines, as there is an intrusion prevention system running on that gateway, which automatically blocks brute force attacks, also requests from untrustworthy classified sources, and requests that have a suspicious pattern. The same holds for the web gateway, which is the gateway that enables the connection to the virtual research environments that I have introduced. So it maps the application in the background on a virtual machine to a certain suffix that you then get attached to the URL that you want to connect to the virtual machines by. The authentication system allows you to connect any identity provider that supports either XAML or OpenID Connect to your SimpleVM installation. So you can choose by yourself which institutes or which identity providers can be used to connect to SimpleVM. So that's basically it. SimpleVM is a platform that enables you to easily and securely use computational resources in the cloud. It comes with a streamlined VM management and has some features on top, which is the virtual research environments, the conduction of workshops in the cloud, and the cluster management. And for you as an operator, it allows you to easily utilize multiple cloud providers at once and take the IDPs of the choice for the login to the virtual machines. Of course, we still extend the feature set of SimpleVM, and our vision is to provide a streamlined workbench for day-to-day work in cloud setups. Thank you for your attention. In case you want to have more information about SimpleVM, feel free to reach out or visit the website. We are currently working on making SimpleVM publicly available. It is not yet, as we are working on a license model, but we are planning to do so in the near future. Thank you very much.
Yeah, we've got about 5 minutes if there's any questions in the room. Any questions? If there's not, oh, you got one over there. I know this is not echoing, but it's letting people online hear the questions. So.
Okay. Okay.
Thanks for your talk. I heard you say Azure a couple of times. So my question is it more like the future, or can I already use your tool, so your SimpleVM in Azure? And the second part is you mentioned Nextflow, which is currently integrated with Azure Batch. So if I would like to use SimpleVM, how would that come into play here then?
Okay, at the moment, we don't have an integration for Azure because the client, as I already mentioned, is tailored to OpenStack, because basically the Denby Cloud, where we introduced this tool back then, is based on OpenStack, or all the cloud sites are based on OpenStack. But the SimpleVM client, like this little component that does the, is communicating with the APIs of the cloud providers, can be adjusted to Azure. So this would be a step to take, and then it should be all. Like, the application itself is built in such a way that you only need to adapt this client, but we haven't done it so far, but we plan to do so in the future. Okay.
And did you have a question?
You just answered it. It's deployed on OpenStack. So is it freely available?
It's not open source yet, but as I said, we are planning to do so. We just have to find a suitable licensing model stuff, but we are currently working on it, and we hope to publish it in the near future.
Any more questions? I had one, you might have answered it already, but the virtual research environments that you showed, they were like preloaded with certain software and tools. Is it quite easy for the users to then add anything they want, any bioinformatics software, pipelines, etc.?
As the users have the ability to, like they have root access to the virtual machines that they get access to, so they can basically install whatever they want on their virtual machines. And the environments themselves are pre-built in these images, so it's only just one click, and then, for example, a VS Code is available. And of course, you can install all would normally use in a VS Code environment that you run on your own device.